This is a solution for the question 3 on S1 from January 2013 for OCR. We're given some information in the question. Start with, we're given the information you can see here. Just make sure in the exam you copy that down correctly, just double check you've copied it down right. And we've got to find the regression line of y on x for this data. So, first thing you need to work out is SXX. And these formulae are given to you in your formula book on page 9. So you can check that you're getting these right as you go. So SXX, which is first, is sigma x squared, take away sigma x, all squared. The case now just substituting the numbers in. So sigma x squared we're given in the question, sigma x we're given in the question, n we're given in the question, and if you substitute that in correctly you get 533,333. You then need to work out SXY, and again you're given these three values in the question, and if you work that out and substitute correctly you get minus 22,100. Then, the next thing to work out is the value of b, which is the slope, the gradient of your regression line, which is your SXY number divided by your SXX number. And again, in the exam, just double check you're writing these down correctly before you do your calculation. That turns out to be minus 0.0414. After you've worked out b, you can work out a, which is the y-intercept of your line, and a is always y bar minus b times by x bar. Y bar is sigma y over n. B we've just worked out, and we're times that by x bar, which is sigma x over n. And if you work out the value of a, you get 124. Then it's the case of substituting all of those values into your equation. So y is equal to a plus, well, it's a negative value, 0.0414x, and that is your regression equation for the first part of this question. Part 2 of the question is asking us to use a regression line that's given to us on the question paper, and they're telling us that the GDP for Tanzania is $1,300, and it tells us at the top of the question that GDP is the x variable. So we've got a graph given to us on the question paper. You need to find the 1300 on the x-axis, go up and across to read off a value, and the value you get if you do this is about 71. So you need to make sure that your answer is 71, and that those values up the side are per thousand. So it's not 71,000, it really is just 71. I know it's tempting to think that, but it's 71 per thousand, so it's 71. Part 3 of the question, it's talking about a country of Nigeria, where it tells us that GDP is $2,400. Give 2 reasons why the regression line is unlikely to give a reliable estimate for the infant mortality rate. Well, the graph we've got at the moment, GDP is going along the bottom, and the data we've got, it stops at 1,600. So 2,400 is way outside our existing data range. So this is a 2-mark question, and you've got to give 2 reasons. The first reason is that the data for Nigeria is outside our existing data range. The second thing, if you look at the graph, the correlation on the graph, if you look at how closely those points are arranged to the line, it's not actually a very strong correlation. So we're talking about that, we'll get you your second mark. So the first mark is that the data for Nigeria is outside our current data range. And the second point would be, actually, if you look at the layout of the points to the line, it's quite a low correlation anyway. And as it's quite a low correlation, that would make our prediction even less reliable. In part 4 of the question, we're given now the value for the IMR in Tanzania, and we have its GDP figure as well. We've got another set of data, another paired set of data in here. And we've now got to work out the product moment correlation for our existing 6 countries and Tanzania added in. Well, the product moment correlation coefficient R is SXY divided by the square root of SSXYY. We have all the values up here for the 6 countries that we had earlier, and we've got the formulae we had before, which we've got as well. So SXY was sigma XY minus sigma Y all squared over n. Now sigma XY for the original 6 countries was 509,900. But now we've got this other value to go in, so we need to add on its x value times by its y value. So that sum you can see there is the new value of sigma xy. From that we need to take away sigma y all squared. Well, sigma y used to be 456, but now there's a 96 being added to it. So sigma y all squared will now become that. N was 6, but now another country's been added to it, so that takes that up to 7. And what you need to do is evaluate that to get your new value for SXY. And if you work that out, I haven't actually got the numerical value here. Yes, I have, sorry. It's 634,700. And now you need to do similar things for your other values. SXX, which is sigma x squared minus sigma x all squared over n. We had previously for sigma x squared a value of 8,700,000. Well, now we need to add into that our new x value squared. So that is our new value for sigma x squared. Then over here we need to take off sigma x. Sigma x used to be 7,000, but now I need to add on my 1,300, and then that is being squared, and that is being divided by n, which we said is now 7. And if you work out your new SXX value, that turns out to be 1,039,000, 10,390,000. No, it doesn't, sorry, that's just the first bit, that's just that bit there. I will change that, sorry. 548,571. Right, then we need to do similar thing for SYY. SYY is sigma y squared minus sigma y all squared over n. Sigma y squared used to be 36262, where now I need to add in my new y value squared. Then over here, sigma y used to be 456, and I need to add in my new y value and then square that to get my new total, and I need to divide that by 7. And if you work that out, the new value of SYY comes out to be 1948.86. Actually, I'm going back and correcting this figure up here, I think for SXY. I think I misread again the wrong number. That value there is just the value of the very first bit, so I'll change that, and that should be minus 19814.3, minus 19,814.3. Apologies for that one. So now I have my 3 values which I can stick into my formula up here. My formula was SXY, which I worked out to be minus 19,814.3, divided by the square root of the other 2 multiplied together. That was 584,571 times by 1948.86, and they are square rooted. And if you work that out, you get an answer of minus 0.606. Quite a lot of number crunching in there, and you have to be very careful that you're adding things, squaring them, or adding things on and then squaring the results. So that was a tricky bit of that question, but quite a lot of number crunching to do there for those 4 marks. The final part of that question, part 5, says the IMR, which was the infant mortality rate, is now redefined as the rate per 100 instead of the rate per 1,000. And the value of R is recalculated for all the 7 countries. Without calculation, state what effect, if any, this would have on the value of R that we've already found. Well, the relationship between the 2 variables won't change. It's just that if a number previously was 96 per 1,000, well, it would now be 9.6 per 100. It's just a scaling, and that will not affect at all the correlation coefficient. So the answer to part 5 is that there will be no effect at all. If they wanted a reason, the reason for that would be that it's just a scaling. The relationship between the two variables has not actually changed.